Hi, and welcome to this presentation about DevOps in an embedded world. I have done this talk at a DevOps Meetup in Munich on the 15th of November 2023. But first to myself, my name is Roman Roth and I am the Chief of DevOps and a partner at Zölke. I work now since 21 years for Zölke. I joined Zölke directly from university as a junior .NET engineer, became then an expert software engineer and then an architect and finally a consultant. And one thing that was always at my heart is how can we continuously deliver value? How can we automate things? And how can we ensure the quality of what we are creating? And when the whole DevOps movement started, I jumped right on top of that, became one of the organizers of the DevOps Meetup Zurich, which is a monthly meetup we are doing. And I'm also one of the organizers of the DevOps Days Zurich. The DevOps Days is a 2-day conference in Zurich, and the DevOps Days, they are all around the world. In all of the big cities there are DevOps Days, and I am the president of the DevOps Days Zurich. You can see clearly that DevOps is something which is very close to my heart. That's also why you see now on my YouTube channel this video. I have all around DevOps, architecture and leadership, more than 100 videos on that channel. And I also post a lot and tweet a lot on my social media channel. So if you want to learn more about DevOps, then please subscribe to this video or to this channel or to one of my social media channels. In my project, I work in different industries for different clients doing DevOps transformations. So when we look at these clients, then these clients have, or these companies have different challenges. And I summarized these challenges a little bit to give you an overview on what these challenges are. So when we look at these challenges, usually they have a legacy system landscape, legacy processes. Also, usually what you can clearly see, a lot of budget constraints. Efficiency is a very important topic in many companies. And getting the right talents is also a big issue for them. And also, usually you have a culture already in a company, and changing that culture is very difficult for these companies, and they are also lacking an alignment between IT and business. These are the top challenges that I see companies have. Of course, you see below, there are more challenges that companies face nowadays. So out of these challenges, I have drawn these pictures. This is sort of what I experience when I'm going to consult these companies. The business in the middle, they have great plans. They are working on these plans and they put these plans into Jira tickets and Word documents. And then they throw it over the wall of confusion to the development team. The development team says, if you want to have that, we can implement that. And they implement something. And then they throw it again over the wall of confusion to the testing team. The testing team looks at that, looks at the specification. It's not the same, but they test something, it's green, and they throw it over the wall of confusion to the operation team. The operation team says, how should we operate that? That will never work in production. But somehow they manage to get it to work, and they throw it over the wall of confusion to the customer or to the business. And they are like, what is that? Will never work. That's not what we wanted. This is not something which we can use. And this is something that I see quite often. And what you can see in blue, there is a value stream in there, but the value stream is completely broken by these walls of confusion. And the wall of confusions, they are coming from the silo organization. We have organizational units like business, development, testing, operation, and of course more. And usually these organizational units don't work on the same goals. They are working on different goals, and this means they are not really aligned. And this is usually a big issue. You also this leads to inflexible and slow processes, and it's not really fun to work in these environments. But we need to dig a little bit deeper where these problems are coming from. So when we look to the past, then we worked in the waterfall process. We planned, we designed, we developed, we deployed, we reviewed, we tested and launched big chunks of applications or products. So in this traditional model, the scope was fixed, the time was fixed, and the budget was fixed. We worked on that and we delivered that. Of course, we had of difficulties with this process. Then in the year 2000, some smart people gathered and they said, in the software, you cannot deliver software like that. We need to have a different approach. And they came up with Agile. And in Agile, you are iteratively creating your product. So you create smaller portions of it and you deliver these smaller portions, so these increments. So when you are going into that mode, then time is fixed, budget is fixed, but the scope is variable, which is great. But the problem is we are working still in projects. But our clients don't want to have a project, they want to have a working product. And to understand that a little bit more, we need to have a sort of a differentiation between these two. So when we look at a project, then a project has a start point and an end point, and it has a set of deliverables and of course costs and resources, which means I want to have in 1 year for that amount of money these 10 features. That is a project. And many companies are still working exactly in that mode, but they are saying they are very, very agile. No, they are not. They are sort of making fake agile and working in a waterfall agile mode. So when we look at what the kind of project is, then you can clearly see that a project is always about maximizing the number of stuff that gets delivered. It's about maximizing the features, maximizing the lines of code, maximizing the tests. It's all about maximizing the thing that gets delivered. And usually it's just more features. Now, that focus is of course not so good. Let's have a look how a product or a product-centric work looks like. So when we look at a product, then in a product mode, we want to understand the customer. We want to solve the problem of the customer. It's all about also analyzing and perhaps also changing the behavior of the customer. So the customer in a product is in the center. When we work in products, then we work on that one feature that solves the problem of the customer. And here you can also see the differentiation. It's not about the 10 features we can or should or need to deliver because we are in a project. It's about that one feature that a customer wants and or that changes its behavior. So it is really about focusing on the customer. And one thing that helps us to go into this product mode is DevOps, because DevOps is a mindset and a culture and a set of technical practices which allows us to organize ourselves across that value stream and bringing all the people together working on that product. So this is what DevOps is. Now, when we look at DevOps, and I said it already, we need to bring all the people together to work on that value stream. And therefore, we need to talk about that term DevOps. Because the term DevOps says development and operation. And now we said it's everyone. Of course, some people want to fix that term because they say nowadays security is very important. So we need to call it devsecops, which is development, security and operation. And another group of people say, no, the business, they are very important. They give us the money. So we need to call it BizDevOps. And you see, this discussion does not lead nowhere. So we need to have sort of a term like DevSec, Bits, ArcComp, QAOps. You can also call it DevXOps or DevStarOps, or we call it DevOps, because DevOps is about bringing all the people, process and technology together to continuously deliver value. This is what DevOps is. Now, in an embedded world, why should you care about that? So let's have a quick look. In the year 2000, in the software world, we had some companies with funny names like Netflix, Google, Facebook, and they were experimenting with these Agile or DevOps methodologies. Nowadays, they are dominating the market. At the moment, today in hardware, we see another bunch of companies with funny names like Tesla, SpaceX, Amazon, also doing that, adapting these lean, agile DevOps methodologies in hardware. And I'm pretty sure they will soon dominate also the market. Do you want to have an example? Here's an example from Elon Musk. You can think of Elon Musk whatever you want, but he tweets or X's quite a lot about Tesla. So here we see one of his tweets on the 7th of October. He says we are going to roll out 10.2 of the full self-driving beta component. So to 1,000 owners with a perfect safety score of 100 and 100. So what this tweet says us is that Tesla's software is modularized. So it means that we have a module and that Elon Musk or Tesla is able to update over the air that module and even go and say, okay, you get a better update of that. And what it also says is that Tesla is able to do canary releases. They are able to give that only to a certain amount of people, like these 1,000 people. It also says that Tesla exactly knows how people are driving and they can calculate a safety score and they immediately know how good you are driving. So they are doing observability, they are doing canary releases, and they have modularized their software. Quite awesome for a car company, which is regulated. So let's have a look. Well, we see some other tweets, but then on the 15th of October, so roughly 8 days later, he tweets, all went fine. We are going to release now 10.3 to another group of people with a safety score 99 to 100. So again, this tweet now tells us that they have got feedback. So they observed this update and that everything went fine. roughly 9 days later, he tweets, "Ooh, we had a problem with 10.3. We are going to do a rollback." And he also says that this is expected to happen. So now we need to make a quick step back. So we are here in a regulated environment where Elon Musk and Tesla is doing canary releases to test software in cars which are driving on the road. And of course, they need to adapt to the regulations. And this is quite awesome what is happening here, because now we have these cars on the road and he is doing even a rollback of the software on them. And not 24 hours later, he's tweeting, "Oh, we found the bug. We are doing a rollout of 10.3.1, which is a fix forward." So in these tweets, you can immediately see quite a lot of things. So Tesla has adapted quite a lot of the methodologies of lean, agile, or DevOps. Tesla is doing quite a lot of these practices like fix forward, canary releasing, rollbacks, observability. All of that is in there, and this makes the Tesla very, very fast in innovating. So this brings us, of course, to the questions, because we saw the challenges, but what do companies want to achieve with DevOps? And in the end, what they would like to have is they want to have more value for money, they want to have a faster time to market, they want to have a better quality of their software, a higher customer satisfaction, and top qualified employees working for their companies. And of course, there are also other things that these companies want, but this is the very important things when they are adopting DevOps. Now, of course, science has looked at DevOps, and there is this absolutely awesome book called Accelerate: The Science Behind DevOps, which I can highly recommend to you to read. I also have an own YouTube video on that very book. But the most amazing thing, and we already talked about these capabilities before in the example of Tesla, what they found out is they researched many companies and looked at the companies, why some of the companies are better than other companies. And they identified 24 key capabilities which are important in order to be fast and in order to deliver high quality products. So let's have a quick look at these 24 key capabilities. They have grouped these 24 key capabilities into 5 groups. The first one is continuous delivery capability. You need to have everything under version control, not only your source code, also your documentation, architecture, also the specification. Everything needs to be under version control. Of course, your deployments need to be automated. You saw that with Tesla. The deployment is automated. You don't need to go and stick in a memory stick. Continuous integration is very important. So continuous code integration, where you reintegrate your code, do the unit testing, quality control. Trunk-based development. So science has found out that you should do trunk-based development, have all on your main trunk and reintegrate as fast as possible. Test automation, very important topic, where you automatically test your software, and with that also the test data management. Have a set of test data which you can use to test your software. You should not use your production database for testing. And then the shift left on security, which means you build in security right from the beginning when you analyze the requirements, and the continuous delivery, where you automate your deployments into the staging environment. So these are the very important capabilities for continuous delivery. Then we have architecture capabilities here, loosely coupled architecture. You saw that in the example of Tesla. They have modules, which means they can update each module. This is also something that I recommend, and empower the teams so that the teams can do their own decisions. Then product and process capabilities with customer feedback. You need to get the customer feedback. They are your customers. You need to get the feedback so that you know if they like your product or if they don't like your product. Value streams, organizing in value streams is very important. Working in small batches, so having small batches which go through your value stream and into production. And you also need to allow that your team can do experiments and innovate and get better. Lean management and monitoring capabilities. Change approval boards are, in the best case, they do no harm to you. In the worst case, they will harm your product and or your process and make your processes slower. That's something that they have found out. You need to have a monitoring capability. You also need to have protective notification, which means you need to get notified when something happens in production. Work in process limits, so that you limit the work in process so that not your teams get overwhelmed with the work, and visualize also the work you are doing. And then the cultural capability. So with the Western organizational culture, there we have three cultures: the pathologic culture, the bureaucratic culture, and the generative culture. In the pathologic culture, when you find a bug or when you cause a bug, you get sort of shot. In the bureaucratic culture, there when you find a bug or when you create a bug, then some huge processes get in place to find out who is really responsible and so on. And in the generative culture, there when you find a bug or when you create a bug, then this will be celebrated because the organization has learned something. Then you see supported learning, so that you continuously learn is very important. The collaboration among the teams across the whole value stream is important. Job satisfaction, that you're satisfied in the job, and all of that needs, of course, a transformational leadership. Now, this is already quite awesome that I have found out these 24 key capabilities, but they also put these 24 key capabilities in relation to each other. So they analyzed it with statistics, and they could find out relates to each other. And in simple words, you can say, when you want to achieve something on the right side, you need to do what is on the left side. And this is a very, very important map for you to use when you are doing a DevOps transformation or even an Agile transformation. Now, this analysis has not stopped with this book. Every year they are analyzing the state of DevOps. Here you see the numbers of the state of DevOps report. And there they are comparing the low performer with the high performer, and the numbers are just insane. 973 more deployments to production when it comes to comparing low performer versus high performer. This is massive. And when you boil all of these numbers down, then you can clearly see that companies which are doing DevOps, they have a faster time to market, they have more value for money, they have a higher quality, a higher customer satisfaction, and top qualified employees. And this is the benefit of doing DevOps. Now, when we look at DevOps, then this is modern software development or modern product development across that value stream, also in an embedded world, which means we need to have things like agile requirements, engineering and backlog management. When we go to code, we need agile software engineering, everything needs to be under version control. When we build the product, then we need to have a continuous integration pipeline which executes automated tests and also checks the security of what we just built. And then when we go to testing, we need test automation, including also test data management. Then we deploy to a staging environment or to a device where we can do further tests. So there we want to have there we want to have these environments, and of course also the automation for automated deployment. And when we are going to release, you could see it in the Tesla example, you want to do canary releases. So you want to release updates over the year to a small group of people to test if everything is okay. And for that, you need to have feature toggles. And when you are continuously deploying, then you also have dark launches where you just do an update, but the feature is not enabled. Then in the operate, when it comes to problems, you want to have a cross-team collaboration where everyone works together, and you want to proactively detect problems before your customers do. And of course, for that, you need to have in the monitor full stack telemetry with visual displays and federated monitoring. Now, one thing which is very important is quality, so built-in quality. And Joe Justice, an agile coach and ex-Tesla employee, which worked at Tesla, said that 50% of the money a Musk company invests into a new product goes into automated testing. And this is quite an important statement, because usually what I see is that only a fraction of the money which is invested in a new product goes into the automated testing. And this usually in the beginning accelerates the product development quite a lot, but in the end you are going to stall because you don't have these automated tests, and then quality is going to decrease. Let's have a look at how we ensure quality. In the traditional model where we had the waterfall, there we had that V model, which you can see here. Someone, a BA, was writing a feature, then another BA was writing the story, and then a developer was writing code. If we were lucky, he or she was afterwards writing tests for that code. Usually we are not that lucky, especially in such a setup. And then sometimes later a tester tests the story, and even some more times later another tester tests the whole feature. So what you see there is this delayed feedback. Usually between writing the feature and testing the feature, easily there can be 3 months or even 6 months between that, or even a whole year. And there you see that that's delayed feedback. That's a huge problem in the old traditional way of testing. Now, nowadays, what we do is we write the feature in a form which is called BDD, behavior-driven development. There we define acceptance criteria in the given, when, then form, which is given the initial state. When we do that action, then we want to see this result. And with that, we are baking quality directly in from the beginning. Also, the story is written in that form. And then when we are going to write the code, the first thing what we are doing is we write the test. We use test-driven development, which is a test-first praxis which we are doing, where we first always write the test. When we have written the story or the feature in this BDD form, we just can copy out these acceptance criteria, and with a tool like, for example, SpecFlow, we can generate the tests for our story in the code. So what you see there is that testing the code and writing the code is gets flipped, and testing the story is then something which is completely automated, also testing the feature. And this is what we call the so-called shift left in testing. And this is agile testing. Now, we of course also need to have the right balance of tests. In the traditional way, it was like this. We had a lot of end-to-end tests, which were usually manual or also partially automated, and they are usually quite expensive and slow. We only have a small amount of integration tests and even a smaller amount of unit tests. And the funny thing is, unit tests are very fast to execute and also very cheap to create. So the agile test pyramid looks like this. There we have a lot of unit tests because we use that test first approach. Then we have some integration tests and only a small amount of end-to-end tests. You can also see that in the traditional pyramid, the focus is clearly on finding every bug. We want to find every bug, and this makes it very, very slow. When you look at the agile test pyramid, there we want to prevent bugs. So it's a risk-based approach where we say what things do really need to work and what things, if they don't work, which can be accepted. So this brings us to this continuous testing where we build quality right in from the beginning. So in the planning, we are using behavior-driven development, this given when then form for the acceptance criteria. We also have a definition of ready, when a story is ready and can go into the coding. Then in coding, we use test-driven development where we first create a test before we write the implementation. And then when we are going to build, then we have the continuous integration pipeline, which executes the unit tests and do the static code analysis. In the testing, we have, of course, the definition of done and do test automation and test data management. When we are going to deploy, there we do production testing. So we execute on the productive system as a subset of the tests. And when we release, then of course we do cross-team collaboration when something happens. In operate, we want to find the bugs before our clients do, which needs productive detection. And for that, we need monitoring with continuous monitoring. So when we look at that, then of course, you see that it is quite a lot to do. And this causes quite a lot of challenges in the teams. Now, when we said that DevOps is a mindset and as a culture and a set of technical practices, and you already could see that when you want to do modern embedded software development, then you need to apply all of these practices. And oh, yes, that is quite a lot which you need to do. And in DevOps, our battle cry is always you build it, you run it, and you own it, which means you need to own the infrastructure, cloud, on-prem, or an embedded device. You need to have runtime like Docker, Kubernetes, your virtual machine. You need to have a continuous integration, continuous delivery pipeline like GitHub, GitLab. You need to have monitoring with Prometheus or Dynatrace. You need to have security with Snyk, SonarQube, and you need to have tools like Jira and Confluence. And you need to have a cost management on top of all of that. You need to have maintenance in there. So you need to maintain all of these tools, integrate all of these tools together. And you need to provide access and identity to these tools so that people can be onboarded and offboarded. And oh yeah, I just forgot. you also wanted to build your app on your embedded device. And that's up there. And you see, ooh, that's quite a lot. Now, think of that at scale. When you have different products that you are building, then easily this looks like this in bigger companies. And what you see is that there is quite a lot of inconsistencies and redundancies. Also, every team reinvents sort of the wheel. You can also see that teams lack the observational experience. There is you don't use any synergies, and the complexity is quite high when it comes to all of these tools. So this means the cognitive load is quite high, and usually what you see is teams are struggling quite a lot when they are doing DevOps. So this brings us, of course, to the question, can you scale DevOps at all? For that, we need to do a quick step back. So what do we want to achieve? And you saw that in the beginning when I asked that question, what do we want to achieve and what are the challenges? So what companies want to achieve in the end is what I will present you now. Here we have an example of a company, and they use here the example of a drone company which creates drones. On the top level, you have the board of directors. The board of directors, they have a vision. At the moment, they have a small drone, they have a small market share. In the future, they want to have a big market share, and they want to have drones for maintenance, they want to have drones for heavy lifting, and so on. So in this drone example, on that top level, you have a portfolio level where you have all the big ideas which are very good for that vision. So out of these big ideas, the board of directors gets that one idea which brings us closer to that vision, which in that case is create a drone for heavy lifting. They give that down to the product level. On the product level, there you have the product managers. They take that idea, this epic, and they are thinking about how can we deliver such a drone? What do we need to change? And they're coming up with features. We need to have a bigger battery. We need to have another motor. We need to have a software update on our central unit. And they give these features down to the team level. On the team level, you already have teams which are working on these parts, these modules of the system. You have a software module, you have a battery team, and you can see they are working in an agile way. That means they have a product owner in there. The product owner takes these features from the product level, and they, together with the team, they are coming up with user stories which are going to the backlog and gets implemented. You also see that they have already this continuous integration, continuous delivery pipeline in there, where they can work on their products, which is highly automated, where you have all of these technical practices which you just saw automated in there. And we also saw that we need to have another team, and here the platform engineering comes into play, which means this team does not need to reinvent the wheel and come up with their own form of continuous integration, continuous delivery pipeline. No, it will be delivered in a standardized way by the platform team, so that this team is set up within no time and they can continuously deliver value. Then we have the assembly, which is fully automated. We are doing continuous integration and, of course, also continuous delivery. It goes to the customer, and we have more value for money, faster time to market, better quality, and top qualified employees. But with that, it doesn't stop, because now, as you also saw in the example of Tesla, we need to continuously monitor, report back problems which we have in the software to the teams so that they can continuously improve. But we also need to report back to the top level, to the board of directors, if we are getting more market share, if the customer is happy, and if the product has the impact which we wanted to have, so that they can make the right decision and potentially adapt the product or even stop that product and go to another product. And this is what we call a digital factory. This enables us to continuously deliver value. You even can see the 3 ways of DevOps in there: fast delivery of features to the customer, then getting feedback, getting fast feedback, and then continuously learning. So in that, as this digital factory, you can clearly see on the top level, you have the lean portfolio management, which connects the strategy with the execution. On the bottom line, you have the platform team, which is the foundation of your digital factory and gives the team standardized platform where they can work on. And then you have the platform team, which are practicing DevOps, which build and run their products and own their products. Let's have a little bit more a look at the platform engineering. In the platform engineering, you have the platform team, which creates a product, which is your platform, which contains all the tools which you need for these products you are delivering. In there, you have application runtime, developer experience, automated DevSecops, your pipelines, access and identity, observability. All of that is baked into this platform and supports the team. The product teams, they are practicing DevOps. They build and run and operate their products. Now, the important thing about that concept is not the platform team is operating the product. The teams are operating the product. The platform team just provides the foundation, the standardization, the standardized tools to these teams, which means when it comes to operate or monitor a system, then the product teams are doing that. The platform team just provides the software and the standard dashboards for these teams. So it's really all about giving sort of the foundation to the product team so that the product team does not need to care about these tools, access and identity and all of that. So the platform team, they are generating value for the teams, and the product teams, they are generating value for the customer. The platform engineering or the platform teams, they are enabling DevOps in product teams. That is what platform engineering is. So when we look at when we want to deliver complex products in an embedded world, then this is clearly a holistic approach. It is not only about DevOps. It is not only about electrical or mechanical engineering or software engineering. It is a complex approach, and also building up such a digital factory is a complex thing. So what you need for that is you need to have architecture which ensures this scalability. You need to have smaller components, as you saw in the Tesla example, where you can deliver over-the-air updates. This means you need to have clearly defined APIs, clearly defined modules, and how they interact with each other. Then, of course, you need to have DevOps with the platform engineering and all of these technical practices which you just saw. And you also saw that you need to do something with the data. This data is very, very crucial, and you need to use that data so that the board of directors can make the right decision, or even the development team. And you need to have a great customer experience. This is very important. You need to have the customer in the center and work together with the customer. And you need to have also agile program delivery. So you need to have a way how these teams are working together, how you are organizing the dependency and doing the backlog management, which brings us to the product management. There you need to align the strategy with the execution. And this is how you deliver complex embedded products with your digital factory. This brings us to this picture here, which is the summary. When you look at that, then you need to develop products. You need to go away from that project thinking where you have a start and an end point into a way how you can continuously deliver value. And for that, you need to have that product thinking. Then you need to do, of course, DevOps, because DevOps is all about bringing all the people, the process and technology together to continuously deliver value. That's what DevOps is. And with that, you need to shift left the whole testing and security. This is important. You need to apply that continuous testing and building quality. And then you need to create a platform which exactly enables that, which enables you to shift left, which enables you to continuously deliver value, which enables the people to do DevOps. And this all is the foundation of your digital factory, which you need to build up on top of this platform. And what you see here is that the platform engineering builds your platform, which is the foundation of your digital factory, and enables your teams to do DevOps. And in the end, this is the way how you can continuously deliver value, how you have more value for money, a faster time to market, better quality and top qualified employees. And as you can see out of that, we are entering now the age of industrialized embedded software development, where we are building up these digital factories. Thank you very much. And if you liked that video, please leave me a thumbs up and don't forget to subscribe to this channel, because I will create more awesome videos like this for you. Thank you.